All right, so let's talk about what exactly happens in the oceans due to this general warming trend that we're finding because of the increase in greenhouse gases in the atmosphere. So that's going to be the topic of 9.6 is ocean warming. And so the learning objective for this section is to explain the causes and effects of ocean warming. And then there's some essential knowledge pieces here that you need to know. So, atmospheric warming basically impacts the oceans. And why that happens is because as the atmosphere warms, that heat is transferred into the ocean. The ocean actually absorbs heat that's radiated back to the earth because of the greenhouse gases. And so those gases actually trap some of the heat inside as that heat is then radiating back. A lot of that heat then gets transferred into the ocean. So oceans actually absorb much of the Earth's heat because water actually has a very high specific heat, and it's estimated that 90% of the warming that we're finding on the planet from the past 50 years has occurred in the oceans themselves. So because of this, it actually, the thermohaline circulation distributes this heat absorbed at the surface to depths throughout the oceans, and then that gets distributed everywhere on the planet. This heat that's absorbed can actually transfer back into the atmosphere, and water actually holds heat for some time. And so this heat can actually get transported or transferred, I mean, back into the atmosphere for decades after it was absorbed. So it's pretty the retain water can actually retain heat for a very long time. All right, and so you're thinking probably, well, who cares? So the ocean's going to get warmer. It's going to be a little bit warmer when I go to the beach, but it's actually a lot more complicated than that. So warmer water, like I've said many times throughout the course, it actually holds less oxygen. So this can actually put organisms outside of their range of tolerance, and it can cause respiratory stress, or it could even cause organisms to suffocate. And so I really like this graphic because it shows what exactly is happening to different ocean organisms because of this general warming trend that we're having in our oceans. So you can see, just to mention a few, the gray whale actually has a longer journey now. Longer journeys mean it's going to spend more energy, it's going to need more food. And if we're already talking about ocean warming impacting food webs, now this becomes a problem because gray whales need even more food because of these longer journeys. We obviously have all heard about the issues with polar bears, but then the leatherback sea turtles are losing breeding habitat because of sea level rise. Green sea turtles are actually, we're seeing extreme sex ratios that are being thrown off because of increased temperatures that happens in some reptiles. If the temperature gets too hot, then mostly females will be born and there won't be very many males. This happens in alligators as well. So alligators would also be impacted by this. And if we don't have any males in a population, then we're not going to be having babies, and then that's a real issue. Wildebeest are experiencing changes in their food supply, and this just goes on and on. You can see everything on this chart. But that is a real problem because it's actually changing the migratory routes and the mating seasons of these organisms. And this just impacts really the entire ecosystem, especially if we're talking about keystone species or species that are lower on the food web. Also works, this impact or these effects are also causing habitat loss. And some examples of that would be like coral bleaching because of the heating ocean. The shallow, sunny waters are actually ideal for algae. So we'll see a lot more algal blooms that are happening. And then the coral is just becoming deeper and deeper because of ice melt. That's a real problem. It's not getting the sunlight that it needs. And so, like I mentioned already, we're seeing toxic algal blooms. Blue-green algae actually prefer warmer water that has less oxygen. And so blue green algae can be very toxic, and it can actually warming the temperature can actually prevent that mixing of water, which we talked about before. And so algal blooms will strip the oxygen out of an environment and cause death. Basically, we'll end up with a lot more dead zones. We've seen this off the coast of Florida. I know there have been toxic blooms that even make it on the national news. And it can actually, because of the toxins that are released from the blue green algae, those are poisonous for uh, marine animals. And so those animals end up dying because of blocked sunlight and then just no oxygen. They suffocate. And then also from toxic chemicals that build up in the water. Okay. And then this graphic is nice because it really shows you everything that's happening to coral. So from coral bleaching to infectious disease to smothering of the coral where it's not getting enough oxygen, destroys the reef structure is a problem. Murkier water because of increased algae, and then that reduces the amount of light that reaches the reef. Lack of food and dispersal of the larvae, and then decreasing growth rates and also the structural integrity of the coral reef system just is decreasing. So all of these things are occurring because of these different changes that are all happening because of climate change. So, and we'll talk about ocean acidification. We're even going to do a lab on that. All right, so what is coral bleaching? That's a concept that you really need to know. So, a coral reef is basically a mutualistic relationship of organisms, and that relationship occur. And remember, mutualism is where both species benefit. And so, it's a relationship between coral and the photosynthetic algae that's called zooxanthellae. And then this algae actually supplies the sugars or the glucose for the coral. The coral supplies the CO2 for the algae. And then it also, both of these things actually impact the detritus, which is the organic matter made by decomposers in this ecosystem. So, coral bleaching. That's how coral reefs kind of survive based on these mutualistic relationships. Algae have a very narrow temperature tolerance, so their range of tolerance is quite narrow. And the algae actually live in the reef ecosystem will leave the reef when the temperature rises. Another issue is that end up with pollutants from runoff that can also force the algae to leave the reef. That's why we're finding people wearing now reef safe sunscreen. That used to be a real problem, but we're also still finding that sediments from runoff or erosion, and then also pesticide use is getting into the waterways. It's building up in large river systems and then making its way to the ocean. Remember, all drains lead to the ocean. We learned that in Nemo. And so all of that will build up in our ocean ecosystems and cause real problems. So what happens with coral bleaching is the coral lose the color because of these different variables. Uh, And this happens because they become stressed. They're outside their range of tolerance, and now they're vulnerable to disease without the algae that's there, that's their main food source. And so that's what coral bleaching is. And they end up becoming white, and then the whole entire reef ecosystem can die. And so the reason they become white is from that lack of algae and lack of mutualistic relationship. And so they basically just look like dead reefs. So here's your practice FRQ for 9.6. Describe one climate change related threat to coral reef ecosystems and describe one climate change related threat to a marine species other than coral. Okay, that's it for 9.6. Our next section is going to be 9.7, ocean acidification. And I kind of mentioned it briefly in these notes. So we'll figure out what all is involved with ocean acidification when I see you guys next time. See you soon.